Welcome back to this next video in which we are discussing inflammatory bowel disease. Okay, so we're currently in the process of studying the pathophysiology of inflammatory bowel disease, and what we've seen so far is that an individual who's going to develop inflammatory bowel disease will develop a CD4 positive T cell that is directed against a peptide fragment of one of the proteins of a commensal of the gut microbiota. Then that commensal will be sampled by the M cells as part of the normal immunosurveillance process. The sentinel cells will decide that that is not a pathogen and therefore will not initiate the innate immune response. However, they double check it with the adaptive immune system, so they still chop up the commensal. They chop up all its proteins into little peptide fragments and present these on MHC class 2 because it's an extracellular microorganism. And they then go to the gut lymphoid aggregates to present these peptide fragments to CD4 positive T cells. Now, in our individual who's going to develop inflammatory bowel disease, you will then have a CD4 positive T cell that is directed against one of those peptide fragments, and therefore the antigen presenting cell will successfully activate that CD4 positive T cell, and it will now start dividing and dividing and dividing. So let's continue on the story. So here we are, we're going to get activation of a CD4 positive T cell. What's going to happen next? So the first thing that happens is you expand that CD4 positive T cell clone, and this is exactly the same as what would happen if we were actually dealing with a pathogen. Okay, this is the initiation of the CD4 positive T cell arm of the adaptive immune system. So the cell divides and divides and divides. So I'll draw this here. So I'll put 5's a nice healthy number. Of course, in reality, you'll get far more than 5. It will divide and divide and divide to get a huge number of identical CD4 positive T cells that are all directed against that same peptide fragment. So I'll try and label this up. This is division occurring here. So after activation, we get division of the CD4 positive T cell. Then, after division has occurred and we've now got a much bigger population of those CD4 positive T cells directed against that peptide fragment, they will then start to differentiate. So next arrow is going to be differentiation, and I'll try and squeeze this annotation in here. Differentiation. Just about. Okay, so this is the differentiation arrow. And when these CD4 positive T cells differentiate, they can differentiate into one of two types of cells. So let me put these in here. A few of them will differentiate into memory CD4 positive T cells. So these ones in green here, these are memory CD4 positive T cells, and these are really, really important. These replace the initial CD4 positive T cell that was activated. This one up here, this is what we would call a naive CD4 positive T cell. To give it its full proper name, it's a naive CD4 positive T cell because it's never been activated before, and now it's being activated by our antigen presenting cell. It divides and divides and divides, and when these progeny of the naive CD4 positive T cell differentiate, some of them will differentiate into memory CD4 positive T cells, which will replace this initial one, and they do the same job as the original naive one, and that's really important in maintaining this adaptive immune response long term. I'll come back to the memory CD4 positive T cells in just a moment. The others, the majority in fact, will differentiate into effector CD4 positive T cells or effector helper T cells. So these ones here are the ones that are actually going to do something. These are the effector CD4 positive T cells, and now it's more usual to start referring to them as helper T cells rather than using CD4 positive. So we'll call them effector helper T cells. Now, before I talk more about effector helper T cells, let me say something else about the memory ones. Let me explain the memory ones. So, let's for a moment imagine if we didn't have any memory CD4 positive T cells, what would happen? We'd activate this naive CD4 positive T cell, it would divide and divide and divide, and all of its progeny would start differentiating into effector helper T cells. Now, effector helper T cells will go and do stuff. They will go and help B cells and other stuff that we'll come on to in just a moment. However, they don't live that long. They live for a few weeks, whereas a maximum a few weeks. Whereas the naive CD4 positive T cell, we know that that lived for years, okay? And it was slowly dividing, remember, to replace itself once it had died, to retain the same clones of CD4 positive T cells as part of the immune system. So, if we turned all of these progeny into effector helper T cells, then they would die within a few weeks, and then we'd have completely wiped out that CD4 positive T cell clone. It would have gone, okay? We wouldn't be able to use that part of the immune system again. We might wipe out all of the CD4 positive T cells of that clone directed against that peptide fragment. That is a rubbish idea. Even though these will be very useful in the short term, of course, what if we get exposed to this microorganism again? Remember, really, that we think we're initiating this against a pathogen. Okay, yes, we're initiating it against a commensal in inflammatory bowel disease, but remember, this is the same pathway that is initiated in response to an actual pathogen. You might be exposed to that pathogen again. You might need to use this pathway again. So you do not want to wipe out your entire clone there. So instead, some of these will differentiate into memory CD4 positive T cells, and these do the same thing as the naive ones. They sit around, they go in the lymph nodes, they go in the spleen, they go in the bloodstream, they go in the lymphoid aggregates within the gut, and they wait to be activated again. And they can be activated again by antigen-presenting cells coming and presenting to them the peptide fragment that they are targeted against on MHC class 2. And if they're activated, they do exactly the same thing as the naive CD4 positive T cells, i.e. they divide and divide and divide, and then their progeny can differentiate again into effector CD4 positive T cells and memory CD4 positive T cells. So they replace this original naive one, and you'll probably end up with far more of these memory CD4 positive T cells than you ever had of the naive CD4 positive T cells. And that's why the second adaptive immune response, if you initiate the adaptive immune response again, will be quicker than the primary one, because you've got a bigger population of CD4 positive T cells that you can activate off that clone, and therefore it will take less time for an antigen presenting cell to successfully come across that CD4 positive T cell clone. Okay, so memory CD4 positive T cells are extremely important, and indeed they're extremely important in the pathophysiology of inflammatory bowel disease, because if they didn't exist, then you would get one episode of inflammatory bowel disease, and once all the effectors had died, that would be it. However, because the memories do exist, you can keep reactivating this adaptive immune response against the commensal again and again and again and again. On and on it goes. And that's why you get this disease for a long, long time, why it's a chronic, sometimes lifelong illness, because the immune response goes round and round and round, can continuously be reinitiated to produce more effector CD4 positive T cells. So these are very, very important, the memory ones. They complete the loop, otherwise it would be a linear pathway and it would have an end. Okay, right. So those are the memory CD4 positive T cells. Now let's talk about the effector CD4 positive T cells, or the effector helper T cells, and this is where it gets a little bit complicated. This is where I start to explain how Crohn's disease and ulcerative colitis are actually really different, because you're going to get a different type of effector helper T cell. So let me just draw some arrows in here. So when one of these T cells here differentiates into an effector helper T cell, there are different types of effector helper T cells, and the ones that are going to be important to us are called the T helper 1 effector helper T cells, like so, and the T helper 2 effector helper T cells. In Crohn's disease, the type that you get is the T helper 1 effector helper T cells, And in ulcerative colitis, the major type that you get is the T helper 2 effector helper T cells. So let me just take a step back and explain this a little bit more. So, there are loads of different types of effector helper T cells. T helper 1 and T helper 2 are probably the most famous, but there is also T helper 17, which I'm not going to talk about because it's not believed to be that important as far as Crohn's disease and ulcerative colitis are concerned. And there's also something called T follicular helper effector helper T cells as well. So there's many different types of effector helper T cells is the important message here. Absolutely all of the different types of effector helper T cells are capable of activating B cells. They are capable of helping in the activation of B cells. Okay? Helper T cells, full stop, they can help B cells. Big point. In inflammatory bowel disease, we are not studying B cells because B cells are not believed to be that important. Helper T cells only help in the activation of B cells. If you haven't initiated a B cell response, then even if you've got effector helper T cells, you're not going to get a B cell response. So in inflammatory bowel disease, we don't think that you have B cell clones directed against the commensals. We think it's a problem with the CD4 positive T cells. So forget B cells for a simple count of inflammatory bowel disease. But know for the background knowledge that all effector helper T cells can assist in the activation of the B cell response, and they are absolutely necessary for the activation of the B cell response. If you just try to activate the B cell response without having effector helper T cells, it will fail. Okay, you have to have effector helper T cells to successfully, fully activate the B cell response. But we're not even beginning in the response. In initiating a B cell response in inflammatory bowel disease, so it doesn't matter that we've got the effector helper T cells. Okay, so enough on B cells, they're not important in inflammatory bowel disease. Helper T cells, effector helper T cells, they don't just help B cells, they have other functions on the side, and it's these other functions that effector helper T cells have which is different between the different types of effector helper T cells. So the different types of effector helper T cells, such as the T helper, that's not what I wanted, laser pointer, the different types of effector helper T cells, T helper 1 cells and T helper 2 cells, both of them can activate B cells or assist in the activation of B cells, but they both have other functions on the side, and those other functions are different between the two. And this is how the inflammation in Crohn's disease is going to be different to the inflammation that occurs in ulcerative colitis, because these two types of effector helper T cells do slightly different things on the side. And depending on the type of microorganism that you are initiating this CD4 positive T cell response to, that will determine which type of helper T cell you want to have. So, let me now talk about what sort of scenarios you want T helper 1 cells for and what sort of scenarios you want T helper 2 cells for, and then we'll sort of start to see how these are going to cause inflammation to occur within the gastrointestinal wall. So let's start with T helper 1 cells, which are the ones that are going to be produced in Crohn's disease. So, T helper 1 cells are produced to help macrophages. Along with assisting in the activation of B cells, they also help macrophages. They help macrophages that are struggling. So you will remember that as part of the inflammatory response, the innate immune system, we bring in white blood cells, and we bring in neutrophils and macrophages as the two major types of white blood cells. Those are both phagocytes. They engulf pathogens and try and break them down, and that's fantastic usually. It has a brilliant effect at clearing pathogens from an area of tissue. However, the neutrophils are very weak phagocytes, the macrophages are the stronger of the two, but some pathogens are too strong even for the macrophages, and the macrophages end up hugely struggling to actually break down those pathogens. This is what I mean by macrophage struggling, and the classical example is in tuberculosis. So let me just draw this here. So, here we have a macrophage, and I'll now get to use my abbreviation, so macrophage, and here is its nucleus. So in tuberculosis, there is an absolutely horrible bacterium called Mycobacterium tuberculosis that is the infectious agent. So I'll write its horrible name down here. And I'm just going over this just to give you a bit of motivation about T helper 1 cells. This isn't particularly relevant to inflammatory bowel disease, but it sets it in nice context. Okay, so there's a horrible bacterium called Mycobacterium tuberculosis that causes tuberculosis or TB. So, this is a lung infection usually. You inhale Mycobacterium tuberculosis down into your lungs, and then what happens? The macrophages within your alveoli, and there are macrophages strutting around inside your alveoli looking for little pathogens that you've breathed in. They will phagocytose the Mycobacterium tuberculosis cells into a phagosome, like so. So here is our Mycobacterium tuberculosis cell inside the phagosome. Now, the macrophage thinks it's doing brilliantly. It's got the Mycobacterium tuberculosis inside this phagosome. However, it now tries to actually break down the Mycobacterium tuberculosis cell, and it hits a problem. This Mycobacterium tuberculosis cell is extremely resistant to being broken down, and the macrophage ends up struggling hugely. In fact, the Mycobacterium tuberculosis is such a nasty cell that it ends up actually being able to divide inside the phagosome. So it laughs effectively at the macrophage. It says, "You're not killing me, I'm going to just laugh at you and start dividing inside your phagosome." So you actually end up with loads of Mycobacterium tuberculosis cells inside this phagosome, and the macrophage is powerless to destroy them. This is an example of where macrophages are struggling. And when macrophages are struggling to phagocytose a pathogen, neutrophils, by the way, will also be struggling. If the macrophages are failing, the neutrophils don't stand a chance. Neutrophils will try their best to attack the Mycobacterium tuberculosis, but they don't stand a chance. If the macrophages can't do it, then the neutrophils can't do it either. So, when macrophages are struggling, this is when you would want to initiate a T helper 1 type CD4 positive T cell adaptive immune response. You'll also get a B cell response to Mycobacterium tuberculosis, but in addition to the B cell response, you'll want to have specifically T helper 1 cells being produced as your type of effector helper T cell. So, how do you actually end up choosing T helper 1 cells as your type of effector helper T cell? Well, it's all done when you actually get the antigen presentation by the antigen presenting cell. So when the antigen presenting cells go to the lymphoid tissue to present the peptide fragments to naive CD4 positive T cells, and they trigger the division and then the differentiation occurs, if they want the effector helper T cells to differentiate into T helper 1 cells, they'll be releasing a certain molecule. And the molecule that's very, very powerful to get T helper 1 cells is a molecule called interleukin 12. So remember, the antigen-presenting cells are very, very clever cells. They're not stupid. They can tell basic things about the pathogen. For instance, this macrophage, it might end up going and presenting peptide fragments to CD4 positive T cells, because even though it's struggling to actually kill the Mycobacterium tuberculosis cells, it will succeed in breaking down some of its peptide fragments. So it will put those peptide fragments on MHC class 2 molecules, and it will take that to lymphoid tissue and activate CD4 positive T cells. It knows that it's hugely struggling to destroy this pathogen and therefore needs a T helper 1 response, so it can then release interleukin 12, and this is what tells these effector helper T cells to become the T helper 1 type. So fundamentally, the message here is that when you're choosing the type of effector helper T cell, it is the antigen presenting cell spitting out signaling molecules that decides what type of effector helper T cell you're going to become, and it will decide it based on the pathogen that it knows it's grappling with. And if it's struggling to destroy that pathogen, and by the way, the dendritic cells would have problems as well, if it's struggling to destroy that pathogen, it will release interleukin 12 so that we get T helper 1 cells being produced. Okay, so now let's see the heroes. What are the heroes going to do? So in Crohn's disease, by the way, coming back to what we're actually talking about rather than tuberculosis, in Crohn's disease, this is going to happen as well. So whatever commensal you're attacking in Crohn's disease, the antigen-presenting cells must feel that this is a difficult commensal to actually destroy, and therefore they must release interleukin-12 when they actually go and present the peptide fragments to the naive CD4 positive T cells to get T helper 1 cells being produced. So let's now see what the T helper 1 cells are going to do. So pen please. So here we have, in yellow here, this can represent a T helper 1 cell. So you'll get absolutely loads of T helper 1 cells being produced. Going back to what happens in tuberculosis, just to give you that famous example before we go on to Crohn's disease, what will happen is these T helper 1 cells will go into the bloodstream, they will come to the lungs, and they will go out in the site where inflammation is occurring, because of course an inflammatory response has occurred, and therefore the microvasculature is recruiting white blood cells, and it will recruit these T helper 1 cells into the lungs. These T helper 1 cells will then look for the pathogen that they are directed against. They will look specifically for antigen-presenting cells, macrophages in particular, but also dendritic cells that are currently fighting the pathogen that they are targeted against. So let me explain this in a little bit more detail. So here is my macrophage. Let's say this macrophage is now in the lungs. It is fighting Mycobacterium tuberculosis. It's losing, but of course it has managed to break down some of the peptide fragments, some of the proteins of the Mycobacterium tuberculosis, and therefore on MHC class 2 molecules here, so this is MHC class 2, it will have peptide fragments of proteins of the Mycobacterium tuberculosis, and it might just have the peptide fragment presented on its surface that this T helper 1 cell is directed against. So remember, we're talking about TB, so this T helper 1 cell is now being initiated against a peptide fragment of Mycobacterium tuberculosis. So the T helper 1 cells will look for antigen-presenting cells, macrophages and dendritic cells that have on their surface MHC class 2 with the peptide fragment that they are directed against, and if they find that, what do they then know? They know that that cell is fighting the exact pathogen that they are targeted against. Therefore, they know that this cell is worth helping, and they give it help. They, in particular, release a molecule called Interferon Gamma. So I'll put this down here, a very powerful signaling molecule, Interferon Gamma, abbreviated down to IFN Gamma, like so. So this stands for Interferon Gamma. And this molecule is a message from the T helper 1 cell here to the macrophage that says, I give you permission to do whatever you need to do in order to destroy the thing that you are fighting. So let me just give you a bit more motivation here. Macrophages and dendritic cells are both very powerful phagocytes, more powerful than neutrophils. They have a huge number of very powerful mechanisms that they can use to try and destroy pathogens. However, they don't initially use all of them. They use a tamed down, a watered down version of the mechanisms to try and destroy the pathogen initially. And the reason is that some of these mechanisms that they have produce a huge amount of damage to the surrounding tissue. For instance, they can produce loads of really, really reactive molecules and throw them into the phagosome. However, some of them leak out and then go into the surrounding tissue and destroy surrounding tissue. So what you have to understand is that to kill the pathogens, some of the killing mechanisms that they can use will end up causing massive damage to the surrounding tissue, and therefore we don't want to use those unless it's really necessary. So macrophages and dendritic cells do not use the full capacity of their killing mechanisms initially. Okay, they can only use those once they've been given permission by T helper 1 cells. So you want to make sure that you've got an adaptive immune response initiated against this pathogen before you actually use all the macrophage and dendritic cell killing capacity to destroy this pathogen. So, when a T helper 1 cell has come along and said, yes, you are dealing with a pathogen that is very, very dangerous because you are presenting me a peptide fragment that I am initiated against, and I know that if I've been initiated against something, this is absolutely a pathogen and we need to destroy it. So it gives the macrophage or the dendritic cell permission to use its most brutal killing mechanisms, and then it does use its most brutal killing mechanisms, and this helps us conquer Mycobacterium tuberculosis. However, Mycobacterium tuberculosis still becomes very, very difficult, even with these additional killing mechanisms, to actually destroy. So what you actually end up forming in Mycobacterium tuberculosis when you get a T helper 1 immune response is structures called granulomas, and I bring these up because these are actually formed in Crohn's disease as well. They're a classic type of inflammation that occurs when you've got T helper 1 immune responses. So, a granuloma is a ball of white blood cells. So this blob here, this is now representing a whole ball of cells, and we can split it into two major layers. So there's the outer portion, and then there's the core. So this is the outer portion of the granuloma, and then there is the core portion of the granuloma. Now, in the core portion of the granuloma, you end up with loads and loads of macrophages, and then in the outer portion of the granuloma, you end up with loads and loads of T helper 1 cells. So let me just put this here. The core is going to contain macrophages, and the outer portion is going to contain T helper 1 cells. And you can see these histologically. They're a classical thing that can form in T helper 1 immune responses. You have loads of macrophages at the center with T helper 1 cells around the outside, and the T helper 1 cells are continuously activating the macrophages in the center with interferon gamma when they realize that the macrophage is presenting on its surface the peptide fragment that they are directed against. So classically, when you get T helper 1 cells being produced as the CD4 positive T cell adaptive immune response, you end up with granuloma formation, and we call this type of inflammation granulomatous inflammation. And indeed, in Crohn's disease, you end up with granulomas being formed. So you end up with a granulomatous inflammation. Okay, so this is a complicated story, so let me just summarize what I've told you so far. So, there are different types of effector helper T cells. One of the major types is the T helper 1 type effector helper T cell, and as well as assisting in the activation of B cells, which isn't important in Crohn's disease, but is important when we're dealing with other pathogens, these T cells are also capable of going and helping macrophages. They are the type of effector helper T cell that is produced when macrophages are struggling to phagocytose the pathogen. And it's not just macrophages, also dendritic cells and neutrophils absolutely will be struggling to phagocytose the pathogen. So when the antigen-presenting cell knows that the pathogen is difficult to break down, it will present peptide fragments to the naive CD4 positive T cells, and it will release interleukin-12 to make sure that when you get the T cell activation, the effector helper T cells differentiate into T helper 1 type effector helper T cells. These come then to the site of inflammation, and when they find macrophages and dendritic cells that are presenting on MHC class 2, the peptide fragment that they are directed against, they will activate those macrophages by releasing interferon gamma, and that allows the macrophages and the dendritic cells to use really brutal killing mechanisms to try and destroy the pathogen. And classically, you end up with these granulomas forming at the site of inflammation. Indeed, in TB, you end up with these granulomas forming, where in the core, you have loads of macrophages fighting the pathogen, and in the outer portion, you have loads of T helper 1 cells, which are helping them to fight the pathogen, screaming instructions in at them. Now, something also that's very important to add on here, especially when we're talking about Crohn's disease, is that when the T helper 1 cells activate the macrophages and the dendritic cells, that results in more inflammation. So not only does the macrophage or the dendritic cell up its killing mechanisms, but it will also start releasing more of these pro-inflammatory mediators, interleukin-1 and TNF-alpha. So, now let's talk about Crohn's disease. So, In Crohn's disease, the commensal that you are initiating this adaptive immune response to must be difficult to phagocytose to some degree, or at least the macrophages and the dendritic cells, the antigen-presenting cells that are going to initiate the adaptive immune response, must think that it is difficult to phagocytose and therefore release interleukin-12. So they're going to go and activate your naive CD4 positive T cell that we've discussed in great detail. It'll divide and divide, you'll get memory cells and effector helper T cells, and now the antigen-presenting cells are releasing interleukin-12 onto these differentiating effector helper T cells, and this causes them to become T helper 1 cells. And these T helper 1 cells will now go to the lamina propria. They're already very close to the lamina propria, of course. They're in this lymphoid aggregate. They're now going to go up here to where the sentinel cells are. And of course, they're now going to bump into these antigen-presenting cells up here, the ones that are remaining behind. And these will have on their surface MHC class 2, potentially with the peptide fragment that they are directed against on that MHC class 2. When they see that, they will activate that antigen-presenting cell. They will assist it in destroying the commensal, and they will also, very importantly, cause it to release interleukin-1 and TNF-alpha. That's why I had to add this bit in at the end, because it's so important. They cause the antigen-presenting cell to release the pro-inflammatory mediators interleukin-1 and TNF-alpha, and of course other pro-inflammatory mediators that we'll come on to later on, but these two are the most important ones. And therefore, you will get an inflammation occurring. You will get exudate being produced, and you will get neutrophils and macrophage coming out of the bloodstream and into the lamina propria. And when you get loads of macrophages coming into the lamina propria, the macrophages and the T helper 1 cells together can end up forming granulomas. So in Crohn's disease then, that's the story. You're going to get a huge amount of inflammation occurring within the lamina propria. You'll get exudate formed, you'll get neutrophils and macrophages coming in, you've got the T helper 1 cells together, the T helper 1 cells and the macrophages will form granulomas, so you'll get granulomas forming big lumps of immune cells in the lamina propria. It can even extend down into the submucosal layer. White blood cells will infiltrate across the epithelium into the lumen, and exudate will certainly infiltrate into the lumen, and this is one of the major things that's going to lead to the diarrhea, the watery poo, because of all the inflammatory exudate going into it. But we'll discuss where the symptoms come from later. We've now seen then where the inflammation is going to actually come from in Crohn's disease. You get the adaptive immune response occurring first, and then the adaptive immune response activates the innate immune response. I hope you saw that. The T helper 1 cells activated the macrophages and the dendritic cells to release the interleukin-1 and the tumor necrosis factor alpha. This arrow here is extremely important. Okay, so that's what's going to happen in Crohn's disease. You're going to get a T helper 1 response in Crohn's disease. Let's now go on to what's going to happen in ulcerative colitis. So in ulcerative colitis, you're going to get a different type of effector helper T cell being produced, which is the T helper 2 effector helper T cell. Now then, what warrants the production of T helper 2 effector helper T cells? This is used when you're dealing with multicellular parasites. So T helper 2 are classically involved in the response to multicellular parasites, where you've got a pathogen that is not unicellular, but is instead multicellular, such as worms, for instance. T helper 2 cells are the ones that are extremely important there. Now, how are these extremely important in multicellular parasites? So let's go through the story then. So again, we're going to have to initiate the CD4 positive T cell adaptive immune response. So we'll start off with our antigen presenting cells here, phagocytosing potentially cells of the multicellular parasite. Of course, these macrophages and dendritic cells and neutrophils, and of course we're initially talking about it in the context of a pathogen, and then we'll talk about it in the context of ulcerative colitis. So we're imagining we actually do have a pathogen, a multicellular parasite, and we're seeing how the T helper 2 cell response works. Neutrophils, macrophages, Resident macrophages and dendritic cells, these are not going to be capable of phagocytosing an entire multicellular parasite. It's far, far bigger than they are. They're single cells, so they can only phagocytose cells of the multicellular parasite, and they're not really good enough to actually destroy this thing on their own. So the inflammatory response, the innate immune response, is not going to manage to destroy a multicellular parasite. It will have a go, but it's not going to do it on its own. It needs the T helper 2 response. So it will phagocytose cells of the multicellular parasite, present peptide fragments on its surface attached to MHC class 2, go and activate naive CD4 positive T cells directed against those peptide fragments, and you'll get division, and they'll differentiate. You'll get memories and effector helper T cells. This antigen-presenting cell, again, it knows something about the pathogen. It knows that this is a multicellular pathogen, and therefore it knows that we need a T helper 2 response. And again, it's going to, when it comes to do the antigen presentation, release a signaling molecule that will tell the effector helper T cells to become T helper 2 type effector helper T cells. And the molecule that does this is interleukin 4. So interleukin 12 is the signaling molecule that causes effector helper T cells to become T helper 1 type effector helper T cells. Interleukin 4 is the signaling molecule that causes effector helper T cells to become T helper 2 type. So you'll get T helper 2 cells being produced. These will then go to the site of infection. And what are they actually going to do? Again, they have to confirm that they're actually at the right site, because these T helper 2 cells, they can go all over the body. You don't want them doing what they're going to do all over the body. You want to make sure that they're actually at the right site, and therefore they need to find, again, a macrophage or an antigen-presenting cell that is actually presenting on its surface the peptide fragment that they are directed against. So let's say that this is a macrophage at the site where the multicellular parasite is, and it's phagocytosed a cell of the multicellular parasite, and on its surface it's covered in peptide fragments of the multicellular parasite. Then when the T helper 2 cell comes along, and I'm just deciding on a colour for the T helper 2 cell, I think we'll have this royal blue colour here. So here's my T helper 2 cell. When the T helper 2 cell comes along, it will then find this macrophage or dendritic cell, and I'll put that this is a macrophage, or it could have been a dendritic cell. Obviously the picture's a macrophage, but the dendritic cells can do this as well. So it will come along to the site of infection, and it will find antigen-presenting cells with the peptide fragment that it's directed against on its surface, and it will then know it's in the right place. It will then know, I've come to the right place, the pathogen that I am directed against is somewhere around here. So it can then do what it needs to do. And what does it do? Well, it releases some very, very powerful molecules. So it releases interleukin 5 and interleukin 13, so more very powerful signaling molecules. And these are the signaling molecules that call in another type of white blood cell, a very, very dangerous, very, very powerful type of white blood cell known as an eosinophil. And these are the cells that we bring in when we are dealing with multicellular parasites. They are very powerful cells. So let me just draw you a picture of an eosinophil. So the reason it's called an eosinophil is it stains fantastically with the dye eosin. It loves the dye eosin. It takes it up very well. And it has a funny shaped nucleus as well, like the neutrophils. It has a bilobed nucleus rather than a trilobed nucleus, however, as neutrophils had. So it's often actually compared to a sunburnt, sunglasses-clad face, because the cytoplasm stains bright red, and then the nucleus looks black. So if you imagine that, it ends up looking like a sunburnt, sunglasses-clad face. So eosinophils are another cell of the immune system. They circulate within the bloodstream, and they are not usually brought in as part of the normal inflammatory response. To bring them in, you have to have the T helper 2 cells coming into the site, releasing these molecules, interleukin 5 and interleukin 13. And when you have interleukin 5 and interleukin 13 at a site within tissue, it will cause eosinophils to come to that area. So eosinophils come into the area. And what do eosinophils do? Eosinophils are the cells that handle multicellular parasites. They are the ones that are actually capable of killing multicellular parasites. They release foul molecules, examples being major basic protein and eosinophil cationic protein. These are absolutely foul cytotoxic proteins that can kill the cells of the multicellular parasite and are extremely effective, therefore, at killing the multicellular parasite. So eosinophil cationic protein is another example. So MBP and ECP are two examples of the horrors that eosinophils can release. These are extremely damaging to your own tissue as well. If you release these, they will kill your own cells as well as the cells of the multicellular parasite. This is why we do not bring in eosinophils unless we absolutely have to. They are not brought in as part of the innate immune response. They are brought in only when you've got T helper 2 cells come to a site, and they have the power to then call in eosinophils to deal with the multicellular parasite. So again, allow me to summarize what I've just told you about the T helper 2 response, and then we'll talk about ulcerative colitis. So the T helper 2 cell response is generally initiated against multicellular parasites. So initially, the antigen-presenting cells will phagocytose cells of the multicellular parasite, present peptide fragments of those cells on their surface, activate naive CD4 positive T cells, and then you'll get division, and they'll start differentiating. And to get effector T helper 2 type T helper cells, you need to release interleukin-4 onto these differentiating effector helper T cells. So the antigen-presenting cells, which do know something about the pathogen that they're dealing with, will then release interleukin-4 so that we get a T helper 2 response. The T helper 2 cells will come to the site where the infection actually is. They'll find antigen-presenting cells, macrophages and dendritic cells that have the peptide fragment that they're directed against on them. They will know then that they're in the right place, and they'll then release interleukin-5 and interleukin-13. They'll call for eosinophils, and the eosinophils will destroy the multicellular parasite, or at least that's the idea. Now, the final bit of this that again is really important because we're discussing ulcerative colitis is that when they meet the antigen-presenting cell that has the peptide fragment that they're directed against on its surface, not only do they release interleukin-5 and interleukin-13, but they also cause the antigen-presenting cell, the macrophage or the dendritic cell, to call for more inflammation to occur. So to release more interleukin-1 and more tumor necrosis factor alpha to cause more inflammation, bring in more neutrophils and more macrophages. And that's really, of course, important in ulcerative colitis pathophysiology. So now talking about ulcerative colitis then. So in ulcerative colitis, you're initiating an adaptive immune response against the commensal. So the commensal gets chopped up by our antigen-presenting cells here. They activate the naive CD4 positive T cell that's directed against a peptide fragment of that commensal. It divides and then it differentiates, and the effector helper T cells are now going to become T helper 2 type. So that means that the antigen-presenting cell must have released interleukin-4. It must have thought that it was dealing with some sort of multicellular parasite. Who can say why? Again, this is a place where the story has a hole in it, but this is what we think must happen. So interleukin-4 must be released, so you end up with T helper 2 cells. These will now go up into the lamina propria. Well, they're already in the lamina propria, but they'll go up to where the sentinel cells are up here. They will then meet these antigen-presenting cells that will have the peptide fragment that they're directed against on their surface, and of course they will then start releasing interleukin-5 and interleukin-13, which will call for eosinophils, how terrifying, and they'll also cause the antigen-presenting cells to release interleukin-1 and TNF-alpha, which will cause inflammation. So, again, that is how the adaptive immune response can then call for the innate immune response, the inflammatory response to occur. So in ulcerative colitis then, going back up to this picture, you're going to get inflammation occurring within the lamina propria. You'll get an exudate, neutrophils, macrophages, and eosinophils coming in ulcerative colitis. And of course, this exudate and the white blood cells will go into the lumen as well. So big difference then that we now understand between ulcerative colitis and Crohn's disease. Crohn's disease is T helper 1 type, and ulcerative colitis is T helper 2 type, this results in the inflammation in Crohn's disease being granulomatous with granuloma formation in the lamina propria, whereas in T helper 2 type in ulcerative colitis, you're not going to get granulomas forming, but you can get eosinophils coming in. Okay, we'll have a break here, absorb that information, and in the next video we'll tie up our understanding of the pathophysiology. We'll look at where all the symptoms are going to come from in inflammatory bowel disease, and we'll tie the whole story together.